All right, let me clear this a little bit. Okay, so we're in 7.3. I know this says 6, but this was going to be your unit 6, and then we changed it to 7. So we're in unit 7.3, talking about the Pythagorean identity. So let's start with, we've heard the, Pythagorean title before. That's giving us the Pythagorean theorem. A squared plus b squared equals c squared. Okay, and if that were this triangle right here, we'd have this hypotenuse side, the, two legs. So I'm going to say that we have like a theta here. So we've got like the, A and B are the legs. Whoops, scribble that out. Are legs. And C is the hypotenuse. Hypotenuse. There we go. So that's our Pythagorean theorem. And we are going to show that this is that we can relate the trig stuff to the Pythagorean identity. So let me jump down here before we do that. We're going to write that Pythagorean identity up there in a second. But let's go back and recall that in a unit circle, it's given the name unit circle because the radius is always 1. So like this is a radius, this has a length of 1. This is also a radius. This has a length of 1. This little spot right here, okay? By definition of unit circle. Okay, so if I were to make a triangle out of this hypotenuse with this angle, theta, the right angle, then I can find sine, cosine, and tangent of theta. So if I wanted sine of tangent, I would want my opposite side over the hypotenuse. All right, well, anything, this opposite side over 1 is just the opposite side. So what is this opposite side? How can I measure this? And that correlates to this y value, this height of this point right here, okay? So that's saying like, all right, in this ordered pair for this point right here, sine of theta is my height, is my y value. Then I can go over here and say, well, what's my x value? What's this side length right here? Because that would help me with the cosine, adjacent over the hypotenuse. And this spot right here is just whatever x value this is. So this is cosine of theta in the x spot of that ordered pair. Okay, so we can rewrite cosine of theta as just x. It is this distance right here, right? Sine of theta is that height. That's the y value. So then if I wanted tangent, I would want the opposite over adjacent side, which is y over x. Okay, so using this information, okay, we know the Pythagorean theorem. We were talking about this guy. We have the side lengths, the two legs of the triangle added together equal the hypotenuse. Okay, so let's equate that to what we're talking about down here. The hypotenuse here is 1. So I'm going to say C is 1 squared. Okay. Now give me a length here. A length could be x. We also said x is equal to the cosine. So I'm going to say this is cosine squared theta, which is just saying square the cosine of theta. And then also I can have the y value, the height of this. So that's sine theta squared, like that. So this is what the Pythagorean identity says. It says we have sine squared theta plus cosine squared theta equals 1. This is the Pythagorean identity that we are going to be using throughout this unit. Okay? One more thing that's going to help, we're going to just kind of name some signs over here. I'm also going to put up some radians because that might help. So remember, this is either 0 or 2 pi. This is pi over 2. This is pi, and this is 3 pi over 2. And then back to 2 pi. So I'm just counting these by half. Like if I were to ignore the pi, I'd have 1/2, 2 halves, which is just 1, 3 halves, right, 3 over 2, or 4 halves, which is just 2. So that's, I like to ignore the pi and just think of these as fractions. I don't know if that's more or less confusing, but there you go. So putting those radians in here, and let's talk about sines of these. Okay, so just a reminder, cosine and x are equivalent. So let's say I've got some triangle in here that I'm talking about. My x distance is positive. My y distance, is positive. So that means that my sine and cosine are also positive. And tangent is positive because a positive divided by a positive is positive. All right, let's try another one. Let's say we were talking about this triangle in quadrant 2. All right, so quadrant 2, my x distance is negative because if I was going to graph this ordered pair, this point, I'd have to go back on the x-axis, so that's negative, which means my y is negative. Wait, sorry, what am I saying? Which means my cosine is negative, my x value. That was just a slip of my brain. I'm like, that's not right. Okay, and then my y value is positive. I'm going up to that point, so y is positive, so sine is positive. Phew. All right, so then tangent is y over x. Positive divided by a negative something is still negative. So there's that one. Then let's say I was talking about this value over here. Okay, so I would have to go back and down to get to that point. So x and y are both negative, which means sine and cosine are negative, and a negative divided by a negative is positive. So my tangent is positive on that one. And last but not least, we're talking about this point right here. Okay, my x value is positive, so that means my cosine is positive. My y value is negative, right? If I were to get to this point, I'd go right and down, so that's negative. And so that means my tangent is also negative. So keep that little table handy. That might help us later on.